Hello and welcome to the next episode of Vieco Live. Today I'm going to present a product that I've built over the past 2 weeks, which is called AL Object ID Ninja. I believe that you have had a chance to already see it, or at least that you know that it is available. I have decided to make this call or actually this live stream to explain what the product is, even though it's mostly obvious, to explain how it is done, and then to discuss where I'm taking it next. And also I would like to hear your feedback. I would like to know what are the features that you would like to have in there. So that said, let's start the demo. Let me just first quickly show what the product does. I'm going to start with the usual suspect of ALGo. I'm going to start a new project. And then I'm going to choose my own server. This is not that important. It's probably going to complain about missing symbols or anything, but that is not what I want to present. Everybody who has developed anything for Business Central in a team and who has used Git or maybe DevOps to manage it knows that once you deploy your branch or push your branch to a remote and then create a pull request, you have no guarantee that there will be no conflict by the time that branch gets integrated into the main line. The reason is object IDs. So for example, here I will start by deleting this demo object, and then I'm going to start by creating a new one. So I'm going to call it demo code unit. And then I'm going to create a code unit. And if I assign number 50,100, there is no guarantee that by the time I push this object and merge that object, this object will not already have been consumed. This is called object ID collision. And this is something that is a reality of every Business Central team. By the time your branch gets integrated, other developers who have no insight into which object IDs you have used will likely have consumed the same number, and there will be a collision. So what I have done is this simple extension for Visual Studio Code, which is called AL Object ID Ninja. So if you didn't install it yet, I invite you to install it from within Visual Studio Code or from Visual Studio Code Marketplace. Once this extension is enabled, what happens when you assign a new number? So first of all, if this is the first time you're assigning a number for this repository, it will ask you this question. It says that Azure Backend has no information about consumed object ID for AL Project 10. Do you want to synchronize? So what does this message mean? First of all, if I assign this number, as I said, other developers who work with you in your team have no way of knowing that you have consumed that number. So there is this Azure Backend, which is public and free for you, that allows you to assign object IDs for every app out there in a safe way. So if I say synchronize, what will happen now is that, first of all, I get this message which tells me that object IDs are now in sync and that I can start assigning them. So what happens when I want to assign the next number? I can see that there is still Microsoft suggestion, but there is my suggestion as well. This suggestion of 50,100, this comes from Object ID Ninja. And here you can see that there is this hint about what this will do. It will assign this number, but there is no guarantee that by the time I press enter, it will actually be that ID. That is because somebody else who is working with the same repository can assign the same number. So assigning a number with AL Object ID Ninja is a two-step process. The first process is me requesting the next number. Now you can see that it is already 50,101. So this stage does not commit that number. This stage merely asks the backend, what would be the next number should I accept it? And then the backend says 50,101. And then when I press enter to accept this, then it goes back to the backend and asks if this number is still available. If not, it would fetch the next available number and assign it here. Also, obviously, it can happen that other developers are working at the same time and requesting the object IDs. So yeah, I'm going to zoom this a little bit. I have got a hint from Waldo. Thanks, Waldo. So this is all that happens. I mean, when you strip it to the bare bones, what you get from Object ID Ninja is really this. It's an extremely simple extension which just does that. So it just makes sure that when you assign next numbers, it is not only looking into your repository, it is looking into all repositories. I've said that this is going to be a presentation of how this is done. I'm going to intermingle that with what the product does. So let's take a look at the source code. Also, the source code is fully available here on GitHub. I invite you to take a look at that and to also participate in it. There are already some issues which are mostly enhancement issues, and there are also some requests which have already been resolved. Let's take a look at the source code. So what is the first thing that happens when you request a number? If you know the anatomy of VS Code extension, you know that typically they have this extension.typescript. So what does this extension do is that it primarily registers this completion provider. Completion provider is nothing but an IntelliSense provider which can jump in and provide suggestions for the specified language. In this case, this is AL. So if I take a look at what this provider does, it is essentially this small class which has this very simple function. So first of all, it needs to determine whether or not it should do something, because IntelliSense is active in AL in a lot of places. So for example, now I still have IntelliSense. I can do something like demo, and then I can do IntelliSense. But obviously, Object ID Ninja must not intercept this IntelliSense. It must only intercept IntelliSense when when Object ID is due. So I have this function getType@position, which uses the symbols from the actual compiler, and then it tries to detect what is the current symbol I'm in. If it fails, it will try to use regex to determine that, and if that fails, it will probably not suggest anything because it realizes there is nothing for it to do. So when it realizes that, when it retrieves the current type that I'm in, if there is no type, which means I'm not declaring an object, then it actually exits. Next step is that it retrieves the manifest, the app.json for the current document. It tries to determine, am I actually inside of an AL workspace? And if not, it also exits. And then the next thing it does is that it retrieves the authentication key. This is something we will talk shortly. And then when it retrieves that, it is ready to ask for the next number. So it goes to the backend, it sends a GET request to this endpoint. I'm also going to talk about these endpoints. And when the endpoint responds, it will show the notification. So it will also log the fact that it has shown the notification. So how does it show? Sorry, not the notification. This is something that we will see that. It will show this notification only under certain circumstances. We will see about them shortly. And then it actually provides this suggestion or array of suggestions, which is essentially this next object ID completion item. So when you do this, it is essentially doing all that. As you can see, it's extremely fast. The request that you send contains the following information. So it reads the app ID. It needs to know for which app ID it's going to do the request. And it reads the ID ranges. So these are the two pieces of information that I read from this manifest. You can see that I'm reading this ID and I'm reading the ID ranges. However, I want to to actually point you to this ID. This is not the raw ID. When I'm reading ID, I'm actually replacing it by the hash. So your ID is safe. If this is your ID, that ID will never be sent to the backend. You can actually check what is sent to the backend by inspecting the AL Object ID Ninja log. So in fact, instead of sending your app ID, it's sending this SHA-256 hash, which is still unique. It uniquely identifies your app without exposing your app ID to a public endpoint. This is a public endpoint, but it is HTTPS, so your communication is secure. It is also pretty secure because this is Microsoft's Azure backend. So it's going to be very difficult for anybody to actually hack into that. But still, just in case, I'm hashing this app ID so that nobody can actually retrieve your actual app ID. Then the next thing that happens, as you can see inside of this next ID completion item, is that it not only provides the information about what should be inserted, it also provides this completion command. This completion command is, in essence, receiving this small chunk of code. So I'm invoking this AL object ID commit suggestion command. This is another registered command that I have created, which receives a callback function. And this callback function is this piece of code, which will again go to the backend, but this time it will retrieve the real ID. So this time it will send a post request. So I'm going to pass it with this commit set to true. So the post request will go to the backend and it will ask the backend again for the next number, which may or may not be the same as the previous one. But this time it is also going to write that into the backend so that this same number is not assigned to anybody else. So when I get this real ID, I'm checking if I didn't receive anything, or next number is not available, or the same ID has been received, I'm simply exiting. But if I've received a different ID, then I'm actually going to replace that inside the editor. So if you're working in a multi-user environment, when you're completing the next ID, you can easily see that it's actually going to get sometimes the next number. I cannot demonstrate it here because I'm doing this demo alone, but this is what happens in those scenarios. Okay, let's take a look at a couple of important things around that. First of all, let's try to make sure if this is actually a safe way to retrieve the next object ID. What I mean by that is, I mean that how can I make sure that if two users request the next object ID from the same app, how can I really make sure that it is not the same ID that is being returned? That's because I'm storing all of IDs in a blob, and now I'm going to show you the backend code. So I'm going to go into my Azure function backend, and I'm going to show you this get next function, which responds when you request the next ID. So what it does in short is that it asks for this first available ID. Every request, it receives the ranges that you actually already have available, that you have consumed, and also it receives the ranges that you are sending from the app. So when you pass those two, if the backend ranges are not in sync, it will get them in sync. So, and then when I know what ranges are available, I'm actually passing, I'm retrieving these IDs, which are already assigned IDs by the object type. And then I'm calling this find first available. So what this function will do is it will find the next ID and return that next ID. And this is soft. It doesn't commit anything. It is simply retrieving the next available ID in fastest possible way to make sure that it can respond really fast. If you take a look at what is the speed at which I'm receiving those IDs, I'm actually going to do that once again. So when I request the next ID, you can see that the next ID that this has took around 185 milliseconds. Sorry, that was not the right one. Let me do it once again. Okay, so this one has executed in 208 milliseconds. So that's total time from you invoking the backend and backend actually responding. So it's really fast. It really retrieves that number in a fast way. What does it do next? Then it first makes sure that if the number is 0, it means that the next number is not available, which means everything is consumed. So it marks this response as not available, and then it returns it to you. So this is the get invocation. What happens when I do post invocation? So let's observe what is happening. So if I accept, and then press enter, there will be a post request, which now took a little bit more, just slightly a little bit more. So what did that do? It has done the same. It has retrieved the next available. Actually, this should be optimized because this should not happen unless I'm actually getting. So I should just fall into this. So what I do here is I call this update consumption. This update consumption is a function which will first read the blob, retrieve the blob, or actually create a reference to a blob which is named by app ID and then /object type.json. And then it will receive that blob. That blob contains all of the IDs which have been consumed. Then it will call this optimistic update. So what this optimistic update does is that it reads the blob, returns the result of that blob as first parameter to my function, to my callback function, and then awaits for the results of that function. When I exit from this function, it will try to save that. And let's take a look. So first it will read the blob, then it will call the callback, and then if everything is fine, it will go and update that blob. And when it is updating that blob, it is passing the E tag. The E tag is essentially a timestamp which specifies, or actually which tells the backend blob service what was the timestamp of this blob when it was last read. And if the timestamp does not match, it means somebody else has already updated this blob. What it will do, essentially, it will go back to this function, run it again, retrieve the next number, return that updated array, and fall back into this update blob. And if E tag still doesn't match, which is very unlikely, it will at that point again go back, and it will repeat this function as often as necessary until it actually gets the next number successfully, or in this case until this number of attempts is exceeded. So if somebody is really launching a denial of service attack, after 100 unsuccessful attempts, it will just fail. It will tell you I failed, and then you will not get your next number. But this is very, very unlikely. We will also see why. So this is what happens in the backend when you are requesting the next number. It is extremely fast for several reasons. First is that blob is extremely fast. Updating blobs and reading from blobs takes very little time. The Azure function that is doing that is placed in the same data center where the storage containers are, so that the latency between Azure functions and the actual blob is minimal. It's under, actually it's unmeasurable. Ping will report it as 0 milliseconds. So in essence, the connection between Azure function and the blob is fast. This optimistic updates, what is happening in here, they're also extremely fast. They read, run your code that updates, and then store. And all of that happens within a couple of milliseconds, maybe just in under a millisecond. And this will only fail if somebody has written the blob between the moment you've read and the moment you've written it, which is, again, under a millisecond. So very unlikely somebody will actually succeed. But if it succeeds, it's going to be the next under a millisecond cycle. So this will really do it fast. So there is no direct locking. Nothing is locked directly. It is optimistically locked, so to say. So it attempts to write, and this is transactional write. It passes this E tag, and blob will not accept the write request if it doesn't have a matching E tag, which is the timestamp. So that's why this is so fast. This is really taking no time. Also, the calculation algorithm for the next number is also extremely efficient. I have benchmarked it. No matter what your ranges are, how large they are, and how many numbers you have consumed, it will also run in under a millisecond. It will just retrieve the next number from all the data it has. So that's about retrieval of the next number. What else does this extension do? Obviously, since I'm talking to this public endpoint, and since you can observe all the communication here, you can really see what is being sent. You can see which endpoints are being contacted. And also, since all of this is open source, anybody can just go and contact the same endpoints with the same information. So if anybody obtains your SHA-256 of your app ID, which nobody should, I mean, you should keep this safe. You should not be sharing this with others. If they obtain that, theoretically, they could send object ID requests. So somebody, well, it's unlikely somebody could launch a successful denial of service attack against the service itself. Somebody could launch a denial of service attack against your app. So if somebody knows your app ID and ranges which you're using, which is again something that not everybody should have access to, but if somebody does, they could theoretically attack the backend, consume all of your numbers, and then leave it there. So you will not be able to consume new numbers. How can you prevent that? There are several things. The first thing is authorization. So right now, anybody can contact the backend on behalf of this app ID. So if you try that, you would succeed. But I can authorize my app. So I can do F1 to start a command palette and then say authorize AL app. When I authorize AL app, well, first of all, this is a dangerous operation. You will see why. So I must be sure that I want to do that. So yes, I'm sure I'm going to authorize my app. So what will happen is that there is this object ID config file, which contains this authentication key. From the moment this file is created, every request that goes to the backend must contain this authentication key. If it does not, it will be rejected. So if I attempt to retrieve the next code unit number, I'm succeeding now because my key is correct. Let me try to hack a little bit. I'm going to add this extra character and then try to invoke. Obviously, it tells me that it cannot communicate with the backend API and that my app authorization is probably missing or wrong. So this is a special, a file with, of special importance. You should commit this file to your repository, and you should not allow users to delete or change the contents of that file. As long as everybody in your team has access to this file, they will be able to communicate to the same backend with the same information about your app, and all users in your team will be able to request new numbers using that authorization key. I've had a question, why is this a file rather than a setting? Well, for several reasons. First of all, this file is strictly per folder. So it belongs to this folder. It's essentially strictly per app. It is not good for any other app. So if you put it into configuration settings, it could be per workspace, it could be per user, and then it would not be good. The second one is this file is relevant for everybody working in the folder. So just like everybody must contain the same app JSON, everybody must contain the same object ID config. So this is not user settings or workspace settings or something like that. This is the extension settings that modify how your extension behaves. So much like you would have any COP files or some other configuration files here, or maybe pre-tier files or Babel files or TypeScript files if you're working in other languages, you will need to have this file if you're working with AL Object ID Ninja. So you create this file, you commit that file, push it to repository so that everybody can use it. Once this file is in your repository, everybody can safely consume next numbers without fear that somebody else would just hijack your object ID range. So that's the authorization. The second thing you can do is obviously you can synchronize. Here I've been playing with these numbers and I'm consuming those numbers without actually consuming them. So not all of these numbers are actually consumed. So I can create code unit this and then code unit and then consume some more numbers and then leave this one in here and then request more numbers. Obviously, only 3 of them are really consumed. Others are marked as consumed and will not be available to anybody. So what do you do in situations when your object IDs go out of sync? Well, you resynchronize. So you start gecko synchronize, and then you synchronize object IDs with the Azure backend. So you click this, and then it asks you, what do you want to do? If you say replace, it will replace the current consumption in the backend with whatever it finds in this workspace. So I will say, yes, I want to replace. And then when I request the next number, it's not going to be 113, it's actually going to be 500. That's because that's the first really unused number. And then when I go, it will be 101. But then 102 is consumed, so I can expect to see 103. Oops. Yeah, the file wasn't saved. I'm going to save this file. Now I'm going to synchronize. I'm going to replace. And then I'm going to request the next number, which is 100, 101, and now it will be 103, as you can see. And then it will be, again, those unused numbers until I get to 109, and now it will actually suggest 110, as you can see, and 11, and then 13. So this is the object ID synchronization. Now there is a feature I'm working on, and for this I'm going to run my extension. So when I open an AL workspace, and let me actually start this one, but that's not a good example. I actually want to open a workspace. Okay, I want to open this one. So there is a function which is going to be called, sorry, I apologize. I'm going to restart this once again. I'm going to just start my extension. And I'm going to open this workspace. Oh, I don't know why it's not there. Yeah, I was pretty sure apparently I haven't pushed it yet from another machine on which I'm developing. So let me explain what the feature will do. That's the feature for when you're starting using Object ID Ninja on a repository where not only a lot of numbers have already been consumed, but also there are multiple developers working in multiple branches. When I do synchronization from within here, it will only synchronize what it can see in my workspace. But anything that is in other developers' branches out there, which is also object IDs, which you must not be assigning, they're not free. So what I will do, what I'm actually working on, is automatic synchronization. When you run this automatic synchronization, it will first ask you for which folders you want to do that. And then for each folder, it will ask you for which branches do you want to do that. And then you will actually specify what you want to do. And then Object ID Ninja will read all of consumed object IDs and synchronize them back with the backend so that you can kickstart working with Object ID Ninja even in very much alive repositories with a lot of branches or a lot of object IDs already assigned. So that's it. That's what I wanted to present. Now I'm going to, pass the proverbial mic to you and address any questions if you have them. No questions? Good. If there are no questions, then I'm just going to close this stream. Any graphical overview plan? Yes. So what we will have in Object ID Ninja, we will have a lot of those, let's say, live information about what is going on, about the environment. So right now, Ninja only puts this stuff here. It shows you this unauthorized. It shows that this app is not authorized. And if I go to this other app that I've just been using, it will show that this app is authorized. So this app is authorized and the exchange is secure. But we will have a lot more of those. So we will have more status bar reporting, but we will also have either an extra button here, which will show you the overview, like you can call it fact boxes, about your repository, about the current object. You will be able to see graphically, for example, which IDs are consumed. You will be able to see whether or not this object is actually consumed in the backend, etc. So there will be quite a lot of that. Yeah. There is another question. Any estimate for the field enum IDs? Well, I've started working on that. The biggest problem that I've stumbled upon is that, unfortunately, AL compiler is not, and I have to be critical a little bit here, not, well, it leaves a lot to be desired, so to say. So let's take a look at what am I doing to obtain the current context where I am. So I go to this get type at position, and I'm going there so I can understand, should I suggest the next number or not, and what the next number should be. So what I do is I'm using the actual symbol provider. This is part of the compiler that is currently in charge of this, of the open document, and I'm asking it for the symbols. And now the problem is that when I'm doing this, it will know that I'm in a code unit symbol. But if I'm doing this, and then I'm here, if I'm about to define the field ID, if this is missing, it doesn't know that I'm actually in the field. So it doesn't, even though this document has quite a number of symbols, it has this table which has children fields, which has, like, I mean, it does understand everything. It still at that point does not know that I'm in a field, even though practically everything is there except for the field ID. So this means that I have to either do regular expressions, which I refrain from because regular expressions are not surefire. For example, regular expression has no way of knowing that there should be no auto-suggestion. It can see that I'm inside a field, but it doesn't see that I'm in a comment. Or to properly make it understand that I'm in a comment is a bit complicated. That's an approach that I'm not going to take. The next approach is parsing it. I already have a parser, and what I need to do is essentially I need to parse the contents of this. I'm currently parsing only this, only the object ID. Now I will need to parse all the way to fields and enum values, and then I'm going to use the parser to tell me where I am. So if I ask my parser, what is the symbol at this position, it will know that this is a field. And then it will tell me, okay, please provide field ID for that table, and then it will ask for that. Then I will need to change backend a little bit, which is not too complicated, but it requires some work. I wanted to have it done by the end of this week. It will not happen. I would say probably next week. Append on my last message, or is it, well, I don't see the last message. Okay, I've come a bit late, but where can I define my object ID ranges? You define them in your app.json. So this is where they come from. So originally there was a bug that only ranges property was read and range property wasn't read. So Object ID Ninja could not understand this. Now it has been fixed. So you define object ID ranges, and this is now completely valid. So if you want to have multiple ranges, you define them here, and that's all. I do not plan to have any other source for IDs than what is in your app.json. There is a request on GitHub, and this request is specifically around, actually I've put it as a feature request. I've described it myself. So if you have multiple apps that all are configured to consume from the same range, and they must not consume from the same, they must not conflict out between each other. So typical examples are on-prem deployments, and also even worse typical examples are hybrid. On-prem is fine, hybrid is not fine, but still I do understand that people developing hybrid are going to use Object ID Ninja. I want to make it possible for them to use it. So what I'm going to do is I'm going to create a possibility to both exclude certain numbers from assignment. You will be able to specify excluded numbers within this file. And also you will be able to join apps together in app pools. And as long as app pools contain the same ID ranges, when you request an ID for an app, it will actually consume it from a pool. So all apps within the same pool will consume from the same ranges. But that's as far as I'm going to go. And this is not the most urgent feature I'm going to, even though I put it as high priority in here, this is not really topmost priority. Topmost priority for me is this Git aware synchronization. So, and that's something that is going to be released early next week. Yeah, hybrid, I don't want, I don't do hybrid. I don't like hybrid, but I understand that people do that. And I don't want to go into validity of that. I advise not to do hybrid, but if you ask me, do I want people doing hybrid to be able to use Ninja? Yes, I do. So that's it. Thank you for answering me. This is really nice tool. Thank you for, yeah, you're welcome. Thank you very much for kind words, yeah. Are there any other questions? Will Microsoft remove object IDs from base app? So last one that I've seen was from a couple of months ago when they explicitly said this is not on their roadmap. Just to address this question a little bit, when Microsoft first released AL language, the guy who was in charge at that time of the team, Stuart Glasson, he said that they wanted to do that, but because of time pressure, they decided not to. And also at that time, it would have been a major brain surgery for a very simple reason. They would have wanted to do that, but since back then hybrid was normal, it would be very, very difficult and dangerous to have a object ID-less compiler working in hybrid scenarios with object ID full scenarios. So because of that, they decided to not invest any time and money into that. I held some hopes for them to remove object IDs, but then, there were object types like, for example, controlled in, that does not require object IDs, and there are others. But when they released enum, which was completely new, where they could have easily gone without object IDs should they really not be necessary for them, the fact that enums contain and use object IDs tells me that they are far deeper intermingled into the bloodstream. It's not just a brain surgery. It would be like total replacement of how that works. So I believe they're not going to do that. So when they say this is not on their roadmap, I believe that is an honest, sincere answer, and that we cannot really expect them to do that anytime soon. Okay, any more questions? Yeah, there was this question from Robert, said that Shaq, can different apps share same object range? Yeah, I have explained, I'm working on that. This is called app pools. In the backend, they are actually already supported. So if you take a look at the backend, we already have create pool and join app to pool. And backend is ready. It's just the front end that needs to be ready. Well, I'm going to see about when I'm going to release that. It will require quite some testing. For me, right now, it's not too important. Marko Tenavac says, hvala stari, nema na čemu stari. You're welcome. So, anything else? If not, I'm going to close this. Yeah, well, I'm going to close this presentation now. Thanks a lot for following. Please keep an eye on this tool. It is going to be alive. I'm going to keep it alive. I'm going to contribute to that. I ask you to also contribute to that. I would like to see your pull requests. I would like to see your product suggestions. I would also like to see your bug reports, anything that can make this a better product and that can drive its adoption in the community. Thanks a lot for staying here with me. Have a nice day, have a nice weekend, and see you in the next one. Bye-bye.